So I'm going to go ahead and get started. So today, like previous meetings, I would like to start with your questions and problems. Is there any questions? Let me check the chat box. All right. Today, I'm going to first I'm going to briefly review the material that we discussed in the last week, and then we will cover chapter 3, which is all about the motherboard. I'm going to skip chapter 2, which is about the precautions that IT technicians need to take when working inside the computer case. You can read that chapter on your own. And if you have any questions, you should let me know. We can discuss it further. So there is no need to put time on chapter 2. So now let's move on to chapter 3, all about motherboard. So in the last week, we discussed the main hardware components of a computer or personal computer or PC. In lab exercise, you work with different type of components like motherboard, power supply units. You became familiar with different connectors that the power supply units provides to the computer, motherboard, CPU, RAM, and other adapters that are also called expansion slots. Today we are just going to focus on motherboard or main board and its main features like socket, ports, buses, um, as well as chipset. Okay, so let me just open a Word document. So we talked about main hardware components. Okay, we discussed motherboard, CPU, RAM, hard disk drive, and power supply unit. Okay, today we are just going to talk about motherboard. Okay, uh, as you know, motherboard is the main circuit board or integrated circuit inside the computer or inside the case. It integrates all hardware components together, and it has elements like sockets, ports, slots. Today we will talk a little bit about bus, which is a kind of data path, and also some about chipsets of the motherboard. We already discussed the form factors, which is the standard for size and the shape of the motherboard that integrates it with other components like computer case and power supply unit. All right. So this chapter 3, is all about motherboard. I'm assuming that you guys read chapter 2 on your own, and in case you have any questions, we can discuss it further. So the main objectives for this chapter include describe and contrast various types and features of the motherboard. By feature, I mean these elements. I'm just going to clean up these other elements. We are just going to focus on motherboard. So we are just going to focus on socket, port, slot, bus, chipset, and form factors. These are the main features of a motherboard. And then In this chapter, we learn how to configure motherboards using BIOS or UEFI firmware. We may not get to cover this part in today's meeting, but on Wednesday or later, we will cover this part. And also we will learn about maintenance of a motherboard, including drive, flashing, and also replacing CMOS battery, and also how to select, install, and replace a motherboard. So this course is all about learning how to assemble a system, taking it apart, troubleshooting a system. We are not going to learn how to fix hardware components like motherboard. If you're interested in those kind of topics, you should take courses like electrical and electronic circuits in computer engineering and electronic engineering departments. Our job as an IT technician is to just spot the fault and also learn how to replace the faulty element. So, motherboard types and features. As you know, motherboard is the most complicated computer component. All devices inside the computer must be directly or indirectly connected to the motherboard to be able to send and receive information to or from other components. And motherboard as well as CPU are the two main elements that we should consider when assembling a computer case. So when we put these elements together, these hardware components together, we have to take a couple of factors into consideration. The first element is the form factor. You know that form factor is the standard that defines the size and shape of the hardware components and also the position of the holes inside the computer case. So when assembling a case, our motherboard, CPU, power supply unit, our CPU must be compatible with the motherboard, and motherboard, power supply unit, and case must be compatible. For example, we cannot install a MicroATX motherboard inside a big case like ATX form factor. So before assembling a computer system, we have to take these points into consideration. And with regards to the motherboard, we have to be careful about the socket. Which socket is appropriate for a specific kind of CPU. So the next element is the processor socket and chipset, and buses and number of bus slots. Bus are kind of data path through which components send and receive information, and the other elements include connectors, slot, ports, and etc. Just a moment, let me turn off your mute all. So if you have any question, please raise your hand or write something in the chat box. All right. So the main form factors, it determines, as I said, the motherboard size, features, and it determines whether it is compatible with the power supply, case, processor, and expansion cards. We have three form factors: ATX, which is the biggest standard. This standard or form factor is used to assemble bigger cases and also servers. MicroATX is used to assemble medium-sized cases, and Mini-ITX for a specific purpose kind of cases like home video, home theater, and etc. So Mini-ITX is smaller than MicroATX and is so known as ITX. Here in this table, you will see all the details in terms of their size, description, and etc. regarding these form factors. This picture shows a Mini-ITX motherboard. These kind of motherboards are used for like home theater, as I said, home theater, or kind of game devices. So the next element that we should keep in mind when assembling a computer and also when matching processor with a motherboard is processor socket. It determines which processor that specific socket can hold. We have two groups of processors, those produced by Intel Corporation or AMD. We have AMD Athlon and Intel processors. So Intel makes different type of server processors as well as personal computer processors. Xeon processors are mostly found in huge computers like servers. So we have about 5 standards for processor sockets. These sockets use different methods to create a kind of contact between connectors of a CPU and also the socket. We have pin grid array socket, PGA, in which pins align in uniform row around socket, and we have land grid array, LGA. It uses some kind of pads instead of pins. And you know that CPUs have kind of delicate pins and connectors. And in order to protect those kind of pins, these kind of standards have been revisioned. Okay, so LGA provides a better protection for CPU connectors. The third standard is called flip chip land grid array or FCLGA socket. You have to look at the manual of the motherboard and also CPU to see which kind of socket that motherboard provides. So, and these are the main standards for sockets which can hold CPUs on the motherboard. And we have a staggered pin grid array and ball grid array and etc. Okay. So this picture shows an LGA socket. Here you see that there is a kind of pad. There is not hole. There are not holes inside the socket. Instead of holes to receive the CPU connectors, it has some kind of pad. This way, the CPU connectors are going to be protected. And we have ZIF sockets, and most of the current processor sockets are ZIF, and we have also socket for AMD processor. AMD processors use PGA socket architecture. Here in this table, you can see the details about these socket standards for AMD sockets and etc. So in order to assemble a computer system, first we need to define which kind of motherboard we want to use. The next element to match with the motherboard is the CPU. So first we have to consider the form factor for the motherboard to fit it inside the case, and the next element is to find out which type of processor our motherboard supports. So we can look at its manual and its guideline to see which processor is compatible with that specific socket. That was all about the compatibility of the CPU and motherboard. Now we want to talk about the chipset, which is the other elements that we should consider about motherboard. Any questions so far? Please give me a feedback in the chat box. Is everybody with me? Okay. All right. All right. Okay. Chipset is a group of chips on the motherboard that works with processor to control memory, motherboard buses, and some peripherals. And the major manufacturers for these chipsets are Intel and AMD. And in Intel chipsets, we have two kinds of bridges, North Bridge and South Bridge. North Bridge is the fastest kind of hub that tries to control the memory module, and South Bridge is the slow end hub which controls the PCI slots. Here in this picture, you see the structure of a chipset. On the north side, you see the fastest kind of chip, which controls the memory modules or RAMs. And we have here the South Bridge, which is the slower version of the bridge in the chipset. It controls drives, PCI slots, and etc. Okay, so this element works with CPU and motherboard to control the buses and also flow of the information between components. Here is the main responsibility of a chipset. We have different standards for chipsets. For example, Intel produces standby bridge chipset, Nehalem chipset, and with their own specific features. You can go over the details of this chipset on your own. And we have AMD chipsets, which has A series and 9 series. A series are designed to support the AMD Accelerated Processing Unit, APU, and AMD 9 series are designed to support AMD processor. They can have up to 8 processors. Okay. So the next important element in the motherboard is bus. Bus is a kind of pathway that establishes communication between hardware components. All of the components like chips, ports, memory modules, sockets, they send and receive informations through buses. So bus, it's like a kind of highway between cities. Through those highways, our vehicles are moving and they send and receive data like vehicles. So bus is a data path. So buses can transmit power, control signal, memory address, data, and etc. And we have 3 types of buses. We have data bus, we have control bus, and we have address bus. Okay. Data bus just transmits information and data between elements. For example, when you run a program and load it from the hard disk drive, it goes into the RAM. and then it exchanges information with the central processing unit to perform calculations. This transmission occurs through these lines that are called data buses. And we have different length like 8-bit, 16-bit, 32-bit, and 64-bit buses. So data bus just transmit data. Control buses, they define who can read from the bus. Suppose a bus as a kind of path between two cities. Okay, so it determines which can and which end can read from this data line. An address bus, it determines where information should be sent and define the address where information should be transmitted and also where the information should be stored in the memory, in the hard disk drive, and etc. Questions so far? So again, bus is a pathway on the motherboard that enables components to exchange information. These buses can carry power, control signal, memory address, and data. And you know that inside the computer, all information and data are in the form of binary, 0 and 1. 0 means there is a kind of electrical signal on that path. When one component, for example, CPU, wants to send something to the memory, it puts a signal with 12 volt or 5 volt on that path. And no signal means 0. So 1 and 0, when to represent binary 1, components put a kind of electrical signal with 12 volt, depending on the component, 12 volt or 5 volts electrical signal, and no signal means 0. And data path side, as I said, we have 8-bit bus, 8, 16, 32, and 64-bit buses. This picture shows buses between memory and CPU, the data buses between these two elements. And we also need bus and expansion slots. The speed of the components inside the computer, especially the CPU, is measured with hertz. Hertz is a unit that measures the number of symbols in a second. And megahertz is equal 10 to power 6 or 1 million cycle per second. Gigahertz is 1 billion cycle or 10 to power 9 hertz. So hertz determines the speed of the components on the motherboard. So motherboard can support different type of PCI slots. PCI version 2, it can carry 64-bit information. And we have PCI-X, it uses 64-bit data path. And its latest revision is called PCI-X3 in this picture. So in this picture, these white slots are called PCI slots. The biggest one is called PCI-X. The small one here, this one is called regular PCI and also PCI Express. These small slots are called PCI Express slots. This picture shows these slots very well. This big one is the PCI, regular PCI. These small slots are called PCI Express slots. And these are used to hold adapters or expansion slots on the motherboard. Mini PCI and Mini PCI Express are mostly used in laptop and portable devices. And we have already discussed ports like USB ports, sound, network, video, eSATA ports, and etc. We have also some internal connectors like SATA, USB, and FireWire. I think that should be enough for today. You can read configuring a motherboard like BIOS on your own. It's just text, and you can check these commands on your computer. You can shut down your system and hold the delete button and go to the system BIOS and see the configuration of your BIOS system. This BIOS determines how these components work together. And you can also see which device is used as a boot up device. Different type of memory, almost all of the components connected to the motherboard can be controlled through BIOS setup. So you can restart, shut down your system, press del, and see all this configuration and see how many memory modules your computers, your motherboard support, what is the speed of your CPU, what megahertz is your CPU, it is either quad core or double core, how many PCI slots, memory modules it supports, and all about the chipset and also buses, data buses, and the control and address buses. So I'm not going to do that because I will have to restart my computer. So you can do this on your own at home and see the configuration of your BIOS system inside your computer. Any questions so far?